A logarithm is actually an inverse function of an exponential function. And the logarithm was devised around the year 1600 by a Scotsman, John Napier, and for the purpose of computation. So I'll get into that a little bit later. But let's talk about it. We call that our basic exponential function, or a simple one, is y equals b to the x. And so this is a form that I'll call exponential form. Now, if we wanted to solve for x, what would it look like? Well, this is where the logarithm comes into play. X will be the logarithm, and we abbreviate logarithm as log, base b of y. So this is called the logarithmic form. Alright, so a logarithm, when it's written, has a base and it has an input value. Y is the input value in this case. And so it's a very simple pattern to learn. You need to be able to go back and forth between these two forms. And I think of it as b to the x equals y. And the base of the log, you always read this as log base b of y, or whatever the number is here. That's the base. There's the base. Okay. So as an example, I'll give you a numerical example. Let's say you had 32 is equal to 2 to the 5th power. To write that in logarithmic form, this would be the log of 32 base 2 equals to 5. So here you see that 2 to the 5th power equals 32. Give you another example. 3 to the negative 4th power is 1 over 3 to the 4th, or 1 over 81. So to write this in logarithmic form, this would be the log of 1 over 81 base 3 equals to negative 4. So here you have 3 to the negative 4 equals 1 over 81. So you need to get become adept at going from logarithmic form to exponential form, back and forth. And it's quite helpful to understanding this whole subject of logarithms, to be able to go back and forth. As an inverse function, yes. If we take the inverse to this, then we'll get the input value x. So x is equal to log of base y base b. Literally, one will cancel the other. For example, let me give you an example of what I'm talking about. The log base b of b to the x equals to x. So here the log cancels the exponent function. Now that only works when your bases are equal. But the log cancels the exponent function, leaving only the exponent of x. By a similar token, I can reverse this. B raised to the log of x, log of y, base b, alright, is equal to y. And so here, the b and the log cancels, and leaving the input value. In this case, I wrote y instead of x, because I was looking up here. But it doesn't matter. This is x, and that would be x also. Whatever this number is up here. Okay. So you see that, in essence, the exponent function cancels the logarithm, and the logarithm cancels the base of an exponent function, leaving the input value. So that's really is an inverse function action going on there. So that comes in very handy as far as solving equations and establishing some nice formula identities that we can use. So anyway, just a little introduction here, and let's do one more real quick example. Suppose that we had the log of 343 base 7 equals to x. Now that's written in logarithmic form. I'm going to write it now in exponent form. So in exponent form, it's 7 to the x power equals to 343. And we can, if you recognize it, that 343 is 7 to the third power, then we can solve this. We can say that x is equal to 3. So 7 to the third power is 343. There you go. So you can see that transforming a logarithm into an exponent form could be handy. And sometimes transferring an exponent form to a logarithm is quite handy, particularly when you get to use your calculator on it. So we'll talk about the calculator shortly.